Okay.
Okay, so give the first question I read for now.
The sum of the odd integers between 10 and 50 is A 60, B 600, C 630, D 1960.
Okay, great. So you handled this question really, really well. So the first thing you did, you
Mhm.
found the difference between 10 and 50. The difference between 10 and 50 is 40, yeah?
Yes, sir.
Right, so 50 minus 10 is equal to 40. And so if it's 40, then we need to figure out the number of odd numbers in 40. So for any given set, for any given set of numbers, wouldn't it alternate between even and odd? So take for instance, two is an even number, three is an odd number, then four is an even number. So it would alternate. So for any given set of numbers, the you would have n over two even and odd numbers. And that's where you figure out yourself because you divide the 40 by 2. So excellent job. You understand what I'm saying, right? So like for every set of numbers, you'd have like if I have 50 numbers, half of that will be even and half of that will be odd.
Yes, sir.
Right. So we have 20 odd numbers. So if we know we have 20 odd numbers, then we could identify what the first odd number is going to be. So between 10 and 50, what's the first odd number?
11,
11, then what?
13,
Right? And then 15, and we're gonna keep going all the way till we reach what number?
49,
Right. And how much terms would I have here?
20.
Perfect. I have 20 terms. So you want to find the sum up to the 20th term. So you're gonna use S of 20. So that's gonna be 20 over 2 because it's n over 2. Then by 2a, now a is 11 plus n minus 1, n is 20, so 20 minus 1, and the difference is 2. I believe you'd have done this exact same thing.
Yes, sir.
All right. So 19 by 2 is 38 plus 22 is 60. So 10 by 60 is 600. Honestly, you handled that question brilliantly. I really, really like where you handled that question.
Oh, thank you, sir.
Because when I was doing the question, I didn't think about it so simply, and I did something differently. I I cannot generalize it a bit more, but how you handle that was lovely. You want to see how I do it?
Maybe. Yes, sir. I was not gonna ask.
Okay, so um, what could we use to represent an odd number, like algebraically?
X?
Nah, can't use X.
Oh,
Okay. Here, let me look at even numbers, right? An even number is any number that's divisible by 2. Yeah,
yes,
that's
sir.
what even number is. So another way to phrase that is an even number is just a multiple of 2. So if I wanted to write an even number, it would just be 2n as an even number, where n could be any number. Once it's a multiple of 2, it's going to be an even number. You understand that?
Yes, sir.
And so if 2n is something I could use to represent an even number, what do you think I could use to represent an odd number?
N divided by 2?
Nah.
No. Oh,
So like, let me show you something, right? Let me just say we had one, two, three, four. Actually, let me just tell it n is equal to 1. When n is equal to 1, what number would that generate? That 2n, what would it generate?
2.
Okay, when n is equal to 2, what number would that generate?
4.
All right, so what happens to the number in the middle? There would be no number in the middle because this is going to generate even numbers. So if I wanted to find what the number in the middle would be, I would need to do what to 2?
Add 1.
I would need to add 1, and that would be 3, right? So if 2n represents an even number, then to get 3, I would have had to say 2n what?
Plus 1.
Exactly. So you understand that I could represent an odd number using 2n plus 1.
Yes, sir.
Okay, great. So using this 2n plus 1, I could figure out what my first n term is and what my last n term is. So my first odd number between 10 and 50 would be 11, you agree?
Yes, sir.
Right? So I could figure out what I'm starting from, what I'm starting with. So I'll move across to positive 1, and that's going to turn to 11 minus 1, which is 10. If I divide both sides by 2, I'm going to get n is equal to 5. All right. If I want to figure out my last term in my series, how do you think I could do that?
Put the 2n plus 1 equal to 49.
Right. And you'll get 2n is equal to 48. And then I'll divide both sides by
2.
2. So what's 48 divided by 2?
24.
Okay. And so if you want to represent this using the sigma notation, do you have any idea so how you might do it?
Mm,
So recall the sigma notation. This is the sigma notation.
oh, the 24 would be on top
Mm-hmm.
as the upper limit. The lower limit would be 5. And
Right.
then a to the nth term would be 2n plus 1.
Perfect. And you can plug into your calculator and you get your answer.
Mm.
Right there. Bro, good notes. Come now. Cooperate with me. Please. Wait. I feel I might just have to copy and paste yeah, I just copy and paste this thing. I'm gonna do that. Copy. All right. So we could represent this statement. We could represent that statement as n is equal to 5 to 24 to n plus 1. Let me know if you catch that.
Could you repeat it?
So like, do you understand how I took this and I wrote it in sigma notation?
Yes, sir.
And check this out. I'm going to plug that into my calculator now. And we'll see that we also get 600. So to plug it into your calculator, I want you to pull out your Casio.
Yes, sir.
Um, I'm not sure if your one is the exact same as mine, but are you seeing the sigma button? It might be on top of another button. Wait, let me get mine.
Mm.
1 second.
Oh, yes, I do.
Okay, it should be above the log base button.
Yes, sir.
All right, so you're gonna press shift and you see the summation come up. So inside, you are going to put 2, and to get the variable, you're gonna press alpha, close bracket, and you should see 2x. I don't know if you see that.
Wait, could you repeat?
All right. So instead of us using n, we are going to use x. So you're gonna Inside the brackets, you're going to put 2, then you're going to press alpha, close bracket.
Okay, yeah.
So you have 2x in your calculator.
Yes, sir.
Then you're going to press +1. Next thing you're going to do, you're going to press the arrow to the right, and that should take you to the lower limit of summation. You're going to put in what there? Tell me, Serena, what do you think you're going to put there?
5,
You're going to put 5. What do you think I'm going to put on top?
24,
I want to press equal. What am I supposed to get?
600.
Bam! Yeah. So that's that. But I like your method more because my method, it kind of relying on a calculator. But Serena, this question here, they could ask this in our paper too. They could give you this statement and they could be like, write that statement in sigma notation. So now you know how to write it in sigma notation.
Yes, sir.
Yeah. All right. But I really love your method. Hey boy. Okay, let's move on to 13. Now, by the way, welcome, Zachary. Zachary, I thought it was just gonna be Serena and I today, I just thought it was, yeah.
Nah, so I was just finishing up some Tuesday.
Okay, okay. You do the homework or no?
Nah, so.
Okay, well, Zachary, come on in scene. Read question 13 for me.
For the arithmetic progression, -12, -7, -2, 3, and 8, the nth term is given by A 5n plus 17, B 5n minus 17, C 5n minus 17, D minus 12 minus 5n.
All right, do you know how to tackle this question?
Nah, so not really. Nah.
Do you know the formulas for an arithmetic progression?
No, see.
You was there in the last class or not?
Nah, so I still had to rewatch the video for that.
Okay, that's why you're lost.
Yeah.
So we would have looked at arithmetic progressions, and the main formulas you have to know here is an is equal to a plus n minus 1d. You use that to find for any term, and s of n. You could use that to find the sum up to any term you want. So let me just write that down here. So summary of arithmetic progression. So first things first, Zachary, how do you know if it's an arithmetic progression? Well, um, each term, wait, so you'll see what I mean by this. And we call this the common difference D. So the main formulas you need to know is A of n. A of n is equal to A plus n minus 1 by D. And Serena, you can just tell Zachary the other formula.
S of n is equal to n over 2 brackets 2a um oh gosh,
Right? 2A plus.
2a n plus n minus 1 multiplied by d.
Right. So Zachary, do you know what a series or a sequence is?
Not think so.
All right. So okay, so here we have minus 12, comma, minus 7, comma, minus 2, comma, 3, comma, 8, going on to infinity.
Yes, sir.
All right, you call this a sequence. A sequence It's just a bunch of numbers that have a common relation. If you could, or it could just be a list of numbers, to be honest. All right, that's what a sequence is. Probably wondering, well, what would a series be? All right, so you see how a sequence is just like a list of numbers?
Yes, sir.
A series would be sum. All right,
Yes, sir.
so you see this first formula, you use this formula to figure out an expression that I could use to figure out for any term in the sequence. So Zachary, if I wanted, I could use this formula to figure out the first term or the 10th term or the 100th term in the sequence without having to manually go there. So you use this to figure out the nth term in the sequence. Nth term. You use this other formula to find the sum up to a specific term. So Zachary, you see how we have like, you see how we have minus 12, minus 7, minus 2, 3, 8?
Yes, sir.
I could use this formula to figure out, say, the sum up to the third term. Was the third term in that sequence?
-2.
Right, so I could, if I figure out that formula, you don't have to add minus 12, minus 7, and minus 2. You could just put 3 into the formula, A and D, and you'll get your answer. So S of n will tell you the sum up to whichever term you want to go to. So Zachary, if you wanted to find the sum up to the 100th term, just use this formula. So you use this formula to find the sum up to the nth term. And obviously n is any number you want.
So the first one is to find the term itself, and the second one is to find the sum up to the term you want.
Exactly.
Right.
So they want us to figure out what the nth term is given by. So they want us to figure out an expression we could use to generate any term in the sequence. I'll show you guys two ways you can attack this question. So Zachary, do you think they want us to use A of n or S of n?
A of n?
Right. Now the A, I was gonna ask you if you know what A is, but I'm not gonna ask you. A is just the first term. A is the first term, right?
Yes, sir.
D is the common difference. That's what D is. D is the common difference. So let me go now. So we're gonna use A of n is equal to A plus n minus 1D. So tell me what formula we're gonna use again. I'm trying to make sure I remember this. What the formula? Let's go again, Zachary.
A of n is equal to A plus bracket n minus 1 bracket D.
Now A plus n minus 1 by D. I'm not sure if you did say plus, but let me continue, Zachary. So tell me, what's the first term in our sequence?
-12.
Right? We're gonna leave n blank because we want to come up with a generalized expression where we could put whatever we want for n. Right, Zachary? Because what if I want to find the 10th term? I'll replace n with 10. If I want to find the 100th term, I'll replace n with 100. So you leave n blank because n could be anything.
Yes, sir.
Okay, what is the common difference? Do you know how to find the common difference?
This is -5n.
You're saying is minus 5?
I think so.
Let me see. No, it's not minus 5. So how are you going to get from this term to this term, this term to this term, this term to this term? So let me show you how you'd find the common difference. To find the common difference, it is just so you use consecutive terms. So we could use term 2 minus term 1. So term 2 is minus 7, that'll be minus 12. Minus 12 is plus 12. So Zachary, what is minus 12?
It's 5.
Yeah, it will be 5. The common difference is 5. And you
Yes,
could
I
you
do
could
it backwards, so
and
that's
you
how I
could
get -5.
If you do it backwards, watch. -12 -5 wouldn't give you -7, it'll give you -17. And if you
Hmm.
look over here, 3 to 8, how are you gonna go from 3 to 8?
You plus 5.
Exactly. So the common difference is 5. That's how each term is linked together. You're adding 5. That's how they
I
progress.
see. I see.
Now you just plug that into the formula. So you see we have brackets. We're going to expand the brackets. So we're going to take that 5 and distribute it across the brackets. So that'll be -12. Then 5 by n. And then what?
-5.
Are you seeing any like terms over there?
-12 and -5, so
Right. That'll be -17. Right. Are you seeing that answer anywhere?
yes, and
Which answer?
C.
Right. Because this is actually the same thing as 5n minus 17.
Yes, and
Okay, Serena, you think you see the trick for this question? Like how to like what you could do to not do any working? See a trick?
I'm not sure, sir.
You're not sure. Okay. So Serena, let me show you how we're gonna do this quickly, right?
Okay.
This formula over here allows us to find a specific term in the sequence. You agree?
Yes, sir.
Okay, so when n is equal to 1, what are we supposed to get for sure?
-12.
We're supposed to get -12 because that's the first term in the sequence. So what you could do is, right, Serena, you could plug 1 into these options and see which one give you a -12. That's the hack.
Oh,
You ever thought about that before?
I did, but not for this question.
Oh, the good thing about add maths and maths, Zachary and Serena, is you don't have to do much work in for multiple choice. You could use the maths against itself to kind of ratchet. So Serena and Zachary, here what I was saying, right? So Zachary, that formula we came up with allows us to find any term in the sequence. So Zachary, when n is equal to 1, that represents the first term. What am I supposed to get for the first term?
-12.
Right. So when n is equal to 1 and I plug it in into these answers, I'm supposed to get -12. Zachary, when I put 1 into this, am I getting 12? Tell me, Zachary, if I put n is equal to 1 into this, am I getting 12 -12?
No.
Or again,
5 plus 22.
again 22, that can't be correct. Okay, what about this one?
You will get -7.
That is wrong as well, because we're looking at the first term. What about this?
Mm-hmm. Yes, so you get -12.
Ah, how about this one? Well, this one definitely wrong. Let me explain why this one definitely wrong. Serena and Zachary, is my common difference -5?
Also,
Ah, so this definitely wrong. This is definitely wrong. This is definitely wrong. Well, let me just be curious, right? If you were to plug 1 into that, you get -17. For Zachary and Serena, all you didn't have to do any working and all you had to do, right, was just plug n is equal to 1 into the options to see which one giving you -12. Cool.
yes, so that makes sense.
Right. 14. The sum of is, so Zachary, I presume you don't know how sigma notations work.
No, sir.
All right. So, you want to explain it to Zachary?
Good try.
All right, bets. So let me just write back this thing a little neater because this scanned copy is horrible. It's atrocious. Paste. All right, so Zachary, at the end of it, you go rate Serena's teaching. I think Serena has the potential to be a good teacher.
I don't know about that, sir.
Okay, maybe I hyping she up too much. All
I
right,
don't think
yeah, Serena, give it a shot. And Zachary, you let me know if you understand.
Yes, sir.
so. Okay, so the number at the bottom of the sign k equals to 1 represents the lower limit of the sequence. The number at the top represents the upper limit of the sequence. So that would be the the highest term that you're going up to, like the 10th term of the sequence or something. And then the 1 over k represents the formula of the a to the nth term.
Mm-hmm. Zachary, you understand that or no?
Yeah, kind of, sir.
Kinda okay. So Zachary, you understand that? Oh, good job, Serena. So Zachary, you understand that k is equal to 1. That's like where we starting from. So
And
that k
the
is equal
top one
to
is the top one is the upper limit and the bottom one is the lower limit.
right. And we call this the lower limit of summation, and there's the upper
Mm-hmm.
limit of summation. This sign you see in here represents summations. You're gonna add. So you're gonna use this to generate the terms. And you're starting off when k is equal to 1, and you're gonna add all the terms you generate. So generate the first term for me,
So we 1 over 1,
right? What's the next term?
1 over 2, plus 1 over 3.
We stop in there, we keep going.
You stop there because 3 is the upper limit.
Yes. So when you add that, what will you get? Wait, before we even do anything, I'll almost show you how we can see the answer immediately. I have a way to see the answer immediately, you know.
Yes, sir.
All right. Um, Zachary, what is 1 over 1?
1.
Okay, and you're adding some fractions to 1, right?
Yeah.
So if you have 1 and you're adding some more things to 1, would that give you an improper fraction or a proper fraction?
Improper fraction.
What is the only improper fraction here?
11 over 6.
Yeah, that's the answer. So you
Hmm.
like understand that trick, right?
Yes, sir.
Because obviously if you have 1 plus something again, you're gonna end up with an improper fraction because it's gonna be more than 1. Yeah. Math's so cool and it has so much different ways you can write for multiple choice, especially. Uh, it's kind of fun. Great. Now we're going to move on to geometric progressions. All right. So Serena, an arithmetic progression progressed by adding a common term, right? A common difference.
Yes, sir.
So arithmetic progression dealt with addition. What do you think geometric deals with?
Subtraction?
Nah.
No?
Because when you think about it, subtraction is just another form of addition. Think about it, right? Like I could add
Mm-hmm.
-5. You know what I mean?
Yeah. Would it be like multiplication and division?
Yes. Yes, Zachary. So like let me give you an example, right? Okay. So, Serena, you notice here that each of my terms is increasing by what? By, would I say like I'm adding a number or am I multiplying by a number?
And multiply by 5.
Zachary, let me know if you see in there, like, are you seeing that to get the next term, you have to multiply by 5?
Yes, sir.
All right. So that's what geometric progression is. To get the next term, you're going to multiply by a common number. And we call that the common ratio. So as usual, A would represent your first term. So in this case, what do you think A would be?
1.
Right? So that would represent your first term. Okay. R. Now, how exactly would you find R? Well, in the last question, I showed you that to find the common difference, it's the next term minus the previous term. But in here, in this rounds, it's going to be Tn plus 1 all over Tn. And what do I mean by that? I mean that it's going to be the next term divided by the previous term. Zachary, could you give me an example of what we're talking about?
Think so, sir.
I think you know. So like, how would I go from 5 to 25? You know it's multiplied by 5, but how would you prove that? How do you show it's multiplied by 5?
Uh, 25 plus 1 over 5.
No, 25 over 5.
Oh,
Let me explain something, right? That Tn plus 1, it just means the next term. Look at what I'm talking about. So this would be T1, also known as A. This would be term 2. This would be term 3. You agree?
yes, sir.
All right. So Zachary, wouldn't this be one more than term 2?
Yes, sir.
So like, if in the denominator, I have term 2, then on top, if it's Tn plus 1, then I'm going to use what term on top?
Term 3.
Exactly.
All right, sir.
And you get E5. Serena, you okay with everything so far?
Yes, sir.
All right, nice. And you see this R over here? This R is called the common ratio. So let's look at the main formulas you need to know for geometric progression and how to prove them quickly. So finding the nth term All right, so we're going to find the nth term for a geometric progression. Let's go. So, Zachary, you there?
Yes, sir.
Okay, so Zachary, let we try to truly understand this thing. Okay. So Zachary, to go from 1 to 5, what to multiply by?
5.
To go from 5 to 25, what am I multiplying by?
5.
25 to 125,
5.
125 to 625.
5.
Okay, you get it just by now.
Yes, sir.
If I want to get the first term is just 1. Am I multiplying 1 by anything?
By 5.
But where's the first term?
1.
So are you multiplying anything? Are you multiplying the first term by anything to get the first term?
Now, sir.
No, the first term just existing.
Mm-hmm.
What about the second term though?
Yes, sir. That one you multiply by 5.
So I'm going to multiply 1 by 5, yeah?
Yes, sir.
All right. The third term now, I would have to multiply the first term. I would have to multiply, like, okay, so the third term is 25, right? How many fives would I need to multiply 1 by to get 25?
5.
No. So look at it again, Zachary.
Mm-hmm.
So we have 1 here, and
Yeah.
we want to go to 25. How many fives would I need to multiply 1 by to get to 25?
So repeat the question.
Okay, so right now we are at 1, and we want to go to 25. How many times would I need to multiply 1 by 5 to get 25? How much times are you going to multiply it by 5?
By 5, sir.
Okay, 1 by 5 is not going to give you 25.
So 25 times.
All right, and 25 is the same thing as what by what?
5 by 5.
Right, I was trying to get you to see this. Watch. To go from 1 to 25, you have to multiply by how much fives?
5 fives.
Now you're multiplying by 2 sets of 5.
Right.
So to get the third term from the first term, it's going to be 1 by 5 by 5. Now, without looking, Zachary, how do you think I will get my first term starting from, wait, how do you think I'm going to get my fourth term, T4, starting from the first term?
So it'll be 1 by 5 by 5 by 5.
Let me see now. So identify the fourth term for me here. What's the fourth term?
125.
And to go from 1 to 125, how much fives are we multiplying by?
3 fives.
Right. I don't know if you're noticing a pattern here. Are you?
Yes, sir.
And so, long story short, we need to come up with a generalized formula. So T of n. Now you notice that 1 was the what term? 1 was the what term?
The first term.
Right. What do we use to represent the first term?
A.
A. So we're going to write A. Now, before we move on, I want to ask you a question. So, Serena, come on the spot and help me. So, Serena,
Yes.
5 by 5 by 5 is the same thing as 1 multiplied by 5 to what power?
3.
Say that again?
It'll be 5 cubed.
Exactly, 5 to the power 3. All right, Zachary, help me with the other one. 1 by 5 is the same thing as 1 multiplied by,
5 squared.
and the other one will be 1 multiplied by 5 to what power?
1.
And then the other one will be 1 by 5 to what power? Use the pattern, just keep going with the pattern.
0.
Yeah. Where's anything to the power 0?
1.
Exactly. Right. So you should be seeing a pattern. So Zachary, when n is equal to 1, what is the power? So like when for the first term, right?
Mm-hmm.
When n was 1, what was the power for 5?
0.
Okay. So when n was 1, the power was 0. When n was equal to 2, what was the power?
1.
Okay. When n was 3, what was the power?
2.
You know, there's a pattern there.
Yes, sir.
So how would I represent that algebraically? So the power would be what? What am I doing with n to get the power?
Yeah, adding 1.
You say you're adding 1?
Yeah.
Nah, take your time. Take your time, watch. Let me run back again. When n was equal to 1, what was the power?
0.
Right. When n was equal to 2, what was the power?
1.
All right. So if you want to get the power, what could you do with n? So right now n is 2 and the power is 1. What you have to do with 2 to get 1?
-1.
Okay. What you have to do with 1 to get 0?
Yeah, -1.
Let me see the pattern holds, right? What you have to do with 3 to get 2?
Yeah, -1.
Right. So you notice that we are multiplying. So we're starting off with the first term, that's 1. And then we are multiplying by 5. What does 5 represent? 5 represents the what?
The common ratio.
Right. So it's AR. And in terms of n, what are you doing with n to get the power?
Yeah, -1.
Right. So I would say AR to the power n minus 1. And that, my friends, is how you get the n term for a geometric series or sequence. And that typically looks like A of n. Even though T of n mean the same thing, they're right, it does A of n. All right, so Serena, that makes perfect sense.
Yes, sir.
I didn't hear. Say that again.
I said yes, sir.
Okay, great. You realize it was the same, almost the same kind of proof when we was doing it for AP. It was like almost the same thing.
Yes, sir.
Yeah, right. So let me ask you a question now. Question. All right, so I want you guys to answer that question for me. What is the 11th term in the sequence? And the sequence I'm talking about is this sequence over here. So Zachary, do you think you're going to keep multiplying by 5 until you inevitably reach the 11th term?
Nah, sir.
Now, if I ask you to find the 100th term, would you keep multiplying by 5?
No, sir.
No, that don't make sense.
So you're gonna be a big number, ain't?
Of course, if you have a big number, Wow, that is a big number. All right. By the way, Serena, we typically, when we doing that, we typically, like you would typically put the power on the outside. So you're right. Like, matter of fact, you probably wouldn't even use powers. I mean, you wouldn't use brackets. You could just say 5 to the power 11 minus 1. Yeah. I wouldn't necessarily advise it. So like, it's not wrong, but it's just not standard. All right, so let me give the answer. So Zachary, tell me what the answer would look like.
You tell me the answer.
Tell me what to write.
Oh, I write the formula again and I write I write 1, 5 to the power 11 minus 1.
Say that again?
Is the first element,
Yeah.
right? So I write 1 and substitute.
Wait, did you write A11?
No.
Right, because the formula is A of n, so A of n. So if you want to find E11, tell me write E11. Or you write E11, but we typically write A of n. So you say A11.
Yeah.
And that will be my first term. My first term is 1. So I go
Mm-hmm.
write 1 by 5 to the power 11 minus 1.
Yeah.
Yeah, and that should give you what you getting for that.
So I get the answer itself.
Yeah,
Yeah, 9,765,625.
right. Cool. Now I have a question, guys. As the value for n increases, so like you generate more terms, is your answer going to get bigger or smaller?
You get bigger. So
Or you get bigger? Serena, you seen that, right? Your values for your next term is going to keep on getting bigger and bigger and bigger.
Yes, sir.
Right. So there's something that I needed to understand. So I'm going to give you another example. So let me just call this question 1, and this is question 2. All right. So like, mm, okay, does that look like a AP or a GP?
GP.
Serena, you see now looking like a AP?
Is it GP?
It's a GP. It's a GP. Right? So my question for you guys is, um, what is the 202? Actually, no, that kind of crazy. Yeah, so that's my question for you guys.
So send me a picture of the answer.
Yes, on my picture. I have a question. Are you seeing that number big or small?
Small too.
Oh, Serena, what do you think? That number big or small?
Mm,
Extremely small. So, Serena, eventually, okay, wait, let me just put something into perspective here, right? Give me a second. Well, like, let me answer the question quickly. So that's gonna be A100, and that's gonna be 1 by, and here what, guys? I know I know we kind of skipping it, but in the exam, we need to show them how you find an R. Eh? So to find for R, you could say a half divided by 1. You need to show them how you're finding for R. So a half divided by 1 is just a half. And my advice is don't just do that for one, right? Do it for another pair. So Zachary, what other pair I could work with if I want to find the common ratio?
A quarter and a half, so
Right. So we'll put a quarter over a half. Right? And you should get a half. Okay, cool. So it's gonna be 1 by a half to the power 100 minus 1. And you're gonna get a half to the power 99. Now, if I were to write that as a fraction, um, actually I can't even do that. It's so like, bro. So that number is 1.5, I'll say like 1.58 by 10 to the minus 30. Do you guys have any idea as to how small to the power minus 30 is?
is it area small?
So Zachary, what does that mean? That means like I have 29 zeros before my first number. That is how small that number is. And I just keep going until I have 1.158. Serena, you could imagine how small the number is, right?
mhm.
Okay, great. Now that brings me on to another thing. That brings me on to convergent and divergent series.
So I thought you was gonna talk about lenses.
Oh. It's the same kind of concept, I suppose. Convergent and divergent series. So what exactly is a convergent series? When you hear the word converge, what do you think about?
Things coming together.
Right, so like in maths, I want you to think of it like the values, it approaching a steady value. It like approaching, it converging to a value, right? And something very, very important. Convergence series, by the way, you would never have a convergent arithmetic progression, eh? Never. Because think about it, Serena and Zachary. If you're constantly adding a number, and you have no choice but to get either like bigger or like a negative number, but the point is your value is going to be increasing. So for an arithmetic series, it will never create a convergent series. However, for a geometric series, it would create a convergent series. So I'll make a note about that. So convergent series happens when R is less than 1. And this would be applicable to a geometric series. Are you understand that? Probably not. So let me just try to explain what I'm talking about. This is an example of what we would call a convergent series. Let me just change the let me just change this. Give me a moment. All right, this is an example of a convergent series. Zachary, I need you to tell me if like you're utterly lost.
Yes, I do think so.
All right, so in a convergent series, you understand that the sum is going to approach a fixed number. And like, let me explain what that means with an example. When you look at this series, right, are the next terms getting bigger or smaller?
Smaller, sir.
Right, Serena, when you look at this series, can you see that the consecutive terms getting smaller and smaller and smaller and smaller and smaller?
Yes, sir.
And we could both agree that eventually they're gonna get so small, it's not really gonna affect your final answer because it's so small.
Yes, sir.
Because Serena, look at the look at the look at the 100 term, look at the 100 term in this sequence. You think, okay, if I add 1.58 by 10 to the power minus 30 to 9, do you think that's really gonna change my answer? Like Serena and Zachary, if I have 9 plus 1.58 by 10 to the power minus 30, what do you think the answer gonna be? Like, what do you think the answer gonna be? Like, practically. Zachary, what do you think the answer would be like, practically?
Like still zero.
It'll be 9.
Oh.
Because this, remember, that's 0.0000000000000.
Mm-hmm.
It's gonna keep going 29 times until it reach 158.
Mm-hmm.
For all we know, this is essentially what? That's effectively what?
Zero.
This is effectively 0. 9 plus 0 is 9. So what I'm trying to say, Serena and Zachary, is that anytime you have a fraction as your common ratio, it's going to create a convergent series, meaning that your values are just going to get so small that it's not going to affect the final sum. I'm coming back. Give me a second. Okay, I'm back. Are you confused or like, are you understand what I'm saying? Like, it would
Yes,
just,
sir. Yeah, I understand what you're saying.
because Zachary, if I have, if eventually in my series, I reach something like 0 point followed by 100 zeros,
So it's basically 0.
Yeah, that basically 0. And
Mm-hmm.
the terms after this is going to be even smaller. Do you think the numbers this small would affect real life? Like this small?
That's it.
Nah. Serena, you understand what I'm saying? Or nah?
Yes, I understand.
So I hope all you understand what I mean here. I'm saying that anytime R is less than 1, meaning that is a fraction, right? You're going to have a convergent series. So I hope that makes sense.
Yes, sir.
Okay, cool. All right. So give me a second. This is the proper thing to write. Right. Yeah, the modulus of R is less than 1. So what do I mean by that? I wouldn't learn about modulus until like pure maths, but let me explain quickly what I mean. Serena, you there? Zachary?
Yes, sir.
All right. So Zachary, let me just say R was negative a half, right? Yeah, Zachary, let me just say R was negative a half. Yeah?
Yes, sir.
So
Yeah.
the modulus of R would just be a half. The modulus just considers the magnitude. It doesn't consider anything else. So like, let me give you another example. If we had negative 4 over 5, what do you think the modulus of R would be?
4/5.
Exactly. So once the raw value is less than 1, it'll give you a geometric, I mean it'll give you a convergent series, meaning that your value is gonna approach a specific value. Yeah. And there's a formula for this. And that formula is as follows. Sum to infinity is equal to E all over 1 minus R. Let me just verify that quickly. Yeah, that's correct. So sum to infinity is A over 1 minus R. So Zachary and Serena, if you wanted to see what value this convergent series approaches, you could use this formula. So let's do it quickly. Because Zachary, and you understand at some point, you're gonna have some terms that's so small, it's not gonna affect anything anymore. Because it could be that small.
Yes, sir.
So let me use this formula now quickly. So what's my first term for this for that series?
1
Right? And what is my common ratio?
half.
Right. Where's 1 over 1 minus a half?
So I get 2.
Yeah, 2. So if you were to add up all the values to infinity, you'll get 2.
So that's crazy.
Because think about it, Zachary, the values could just keep getting smaller and smaller and smaller. So like it reach a point where it's just so insignificant. It could just like this whole sum would just produce 2. Yeah. Serena, you could kind of visualize it because I mean it's gonna be 1 plus 0.5 plus 0.25 plus 0.125. And I think you could see it like eventually it will get so small, the final answer will just approach 2. Right. Let's look at divergent series now. So if convergent means that the terms getting smaller and smaller and smaller, what do you think would happen for a divergent series? Somebody tell me. So like conversion means that the terms getting smaller and smaller and smaller. So what do you think would happen for a divergent series? Anybody want to tell me?
Terms getting bigger.
Right. So you would say that the sum blows up. Yeah. Right. Right. So the sum blows up to either positive infinity or negative infinity. All right. So Serena, a convergent series happens when R is less than 1. So where do you think a divergent series would happen?
When R is more than 1.
Exactly. So when the magnitude or the modulus of R is more than 1. And this obviously this would only be applicable to, well, this is applicable to both geometric and arithmetic progressions. Because you understand for arithmetic progression, you just keep adding, adding, adding. If you keep adding, 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 eventually, like you're not approaching a value, you're just getting bigger and bigger and bigger. But for this instance, we're just considering geometric series. But I want you to understand that all arithmetic series are divergent, generally speaking. But if we're looking at just geometric series, then when R is more than 1, you'd get divergent series for and this would be for geometric progression. Right? Geometric series. Could any of you guys give me an example of a divergent series quickly? Could you come up with one? I'm gonna ask Serena to come up with one for me. Yeah, Serena, a way to come up with a divergent series quickly for a GP.
3, 9. Wait, no. 3, 6, 9, 18.
Or 3 plus 6. Wait, 3 plus 6 for GP, yeah? So 3. Serena?
Sorry, so it
Mhm.
will be 3 plus 6 plus 9 plus 18
Wait,
plus.
wait. Nah. It's sounding like a common difference. A common ratio, there's 2. So it could be 3, 6, 12. Wait, Serena, wait, what is your common ratio? Which common ratio you want to use?
I think it was supposed to be 2, but I mixed up how it goes.
Well, that's all right. Continue from here. So 3, 6, 12.
24, then 48.
Right? And we could just keep going, right?
Mm.
So do you understand, Zachary and Serena, do you guys understand that the terms are getting bigger and bigger and bigger? So this value, the sum to infinity here, if you just keep adding, it would just approach positive infinity. Are you understand what I'm saying?
Yes, sir.
Yes, sir.
And quickly tell me, what would R be in this case? R would be equal to what here? What would R be equal to? The common ratio for this question.
2.
2, sir.
Right, 2. So you would say, since R is more than 1, the series diverges. Everybody okay with that or not? So they might ask you to justify why it's a divergent series, and you would have to say since R is more than one, the series would diverge to positive infinity and whatnot. Over here, for this question above, Serena, tell me what statement you would have to write if they ask you to justify why is a convergent series. What statement would I write to justify that is a convergent series?
It would be since the magnitude of R is less than 1, it's a convergent series.
Wait, say that again?
Since the magnitude of R is less than 1,
Okay, I'm barely hearing you. Say that again?
since the magnitude of R is less than 1,
Right? We would say the series converges, and we know that it would converge to what? Thomas Zachary, what would the series converge to?
Negative 100.
No, nah, no,
Negative infinity.
no. If it converging, that means it's approaching a value, you know. That
Oh,
negative infinity means that it getting bigger and bigger and bigger and bigger and bigger.
oh. So it converges to 2.
Yeah, it converges to 2. Mhm.
Oh,
So anytime they ask you to figure out what value the series converges to, you have to find for some to infinity. So that's what you're looking out for any questions. And my mistake, it really supposed to be convergent series. And it was sung a bit sus. Yeah. Yeah, it's supposed to be convergent series. I don't know why I write that. So convergent and divergent. Uh, okay, cool. Yeah, so that's the notes for that. Is there anybody confused at all? Can you now distinguish between a convergent series and a divergent series?
listen,
Okay. Zachary, what about you? You good?
yes, sir.
All right. And that brings me to the second point. For a geometric series, you have two S of n formulas. When R is more than 1 and when R is less than 1. So let me just show you that quickly. Yeah, so you have a um quite a bit more formulas to know for geometric progression. Yeah. All right, give me a second, guys. I'm just check something real quick. Yeah, so that's correct. I just had to check. And do you guys remember the S to S of infinity formula? The sum to infinity for a geometric progression? Guys, do you all remember the S of infinity formula? The sum to infinity formula for a geometric progression?
Yes, sir.
All right, nice. That's A all over 1 minus R. So take whatever you had a copy down and we'll do a recap. So I'll do a summary of everything and then we'll do a past paper question and call it a day. So copy where you have to copy. Zachary, tell me anything confusing, yeah?
Nothing, not really.
Okay, cool. All right. To save some time, take a screenshot and let me move on to the summary. I want to do a summary table going through everything you need to know for arithmetic progressions and geometric progressions, right? So I'm going to move on now. All right. So, Zachary, I'm gonna if you're there.
Yes, sir.
All right. So since you wasn't there in the last class, um, let us do a quick summary. So we're gonna start off with arithmetic progressions. Right. I hope I spelled that correctly. Yeah, I did. Thank God. So let me give you an example. So an example of an arithmetic progression would be 7, 9, 11, 13, 15. They get the idea, right?
Yes, sir.
So this would have a common difference, right? So an arithmetic progression has a common difference. They have a common difference. And the common difference, D, would just be Tn plus 1 minus T of n. So the next term minus the previous term. So that's what arithmetic progressions have. They have a common difference,
Yes, sir.
right? So for this one, the first term is 7, and the common difference would be what? Tell me, what would the common difference be?
2, sir.
Yeah, the common difference would be 2. Cool. So there's that. Something else you have to know. You have to know the formulas associated with this. So you need to know the formula for A of n. What's the formula for A of n?
So that is A plus bracket n minus 1 bracket D.
Right? What's the S of n formula?
Yes, I don't think I remember that one.
All right. So that'll be n over 2 by 2a plus n minus 1 by d.
Yes, sir.
So that's essentially all you have to know for arithmetic progressions, right? Let's look at geometric progressions now. So could you give me an example of our geometric progressions? I mean, a geometric progression.
So example of a geometric progression.
Yeah, give me an example.
So the geometric is when you multiplying, right?
Yeah, when I have a common ratio.
So you could 2, 4, 8, 16.
Yeah,
Yeah.
yeah, we could do that. So to get each term, you're multiplying by,
Multiplying by 2.
right? So A would be equal to 2, and the ratio, the common ratio is
2.
right. Geometric progressions don't have common differences, they have common ratios. And the common ratios is denoted by a R. What's in common ratios? Just say it's a common ratio. So the common ratio is denoted by a common R, and that formula is Tn plus 1 all over T of n. So what does that mean? That means the next term divided by the last term. Right. For this, you need to know the A of n formula. So the A of n formula for this, do you remember it? Zach,
I don't think I remember.
we, all right, let me go back to, all right, what was the formula?
A of n is equal to A by R to the power n minus 1.
Right. You know that, right? A r to the power n minus 1. Cool. And there are two formulas for S of n. The first formula is A. Um, what- did you get a chance to copy it down or not?
Nah, sir.
All right. So the first formula is A by 1 minus r to the power n all over 1 minus r. And you use this formula. Let me show you a simple way to remember this, right? Zachary, we wouldn't want a negative answer. And what I mean by that? What do I mean when I say we wouldn't want a negative answer? Well, in the denominator, it's 1 minus r, and we don't want a negative number. So do you think r would have to be more than 1 or less than 1? If I don't want a negative number here, would r have to be less than 1 or more than 1?
Less than one, sir.
Yeah, because if it was 1 minus 5, that'll give you a negative answer, right? So that's an easy way to remember it. So you use this one when the magnitude of r is less than 1. Then there's another formula for S of n, and that is A. And in this, and the only difference actually is just switching it, and it's just switching it around. So it will be r to the power n, right, minus 1 all over
1 minus r
nah, you're switching it around.
or 1 plus r.
Nah.
Oh,
A way as remember it is like look at this. So 1 minus r on top and 1 minus r on the bottom. So r to the power n minus 1 on top, we think gonna be in the bottom.
r minus 1.
Right. And if you want to avoid a negative number, r would have to be more than 1 or less than 1. Think
More
about it.
than one, sir.
Right. Consider 5 minus 1. 5 minus 1 would give you a positive whole number. So you want r to be more than 1, right? You confuse or you understand? Like if r was if r was a half minus a half again minus a half, we don't want a negative number. But if r is more than 1, like so we just say 5, 5 minus 1 will give you a whole number. A positive number, I mean. Serena, you understand the way to remember it? Or not?
Yes, sir.
Okay. And then there's another formula for sum to infinity. Was the sum to infinity formula? Sam, Serena, remember
So
that?
that one is E over 1 minus r.
Right. A all over 1 minus r. And that's essentially all you have to know.
Yes, I can take a screenshot of this.
Yeah, let me just neaten it up a bit. Put it into our table. Yeah, you take a screenshot of this. All right. So you know, Zachary, I have the screenshot.
Yes, sir.
Yes, sir.
All right. Well, let me do a past paper question now. So what did we cover? We covered what is a series with a sequence. We looked at arithmetic progressions. We looked at geometric progressions. We looked at sigma notation. So we should be well equipped for some past paper questions. So let's go. All right. So I'm giving you all 5 minutes to attempt something. Yeah, take 5 minutes. So by 6:50, I should have an answer.
So for that first one, you had a show working, or you could just plug in a calculator.
You have to show looking.
Or
All right, 2 more minutes. All right, time is up. Serena and Zachary, did y'all come up with anything?
Not sure how to evaluate D.
Okay, it's simpler than you think. All right, Serena, did you get your really 2 questions?
I did something.
Say that again.
I I got something, but I'm not sure if I did it the right way.
All right, well, let me see. Okay, so Zachary, so this will tell us the lower limit of summation, so what we starting off with, and this will tell us what we ending off with. This is going to allow us to generate the terms. All right, so Zachary, let me just copy this quickly. Yeah, so Zachary, could you tell me what the first term would be?
0.
No. So remember this, you're using this to figure out what the first term, you're using this to generate your terms, right? You're using that to generate your terms.
Oh,
So what am I going to plug in into this to generate my first term?
so 5 to the power 0 minus 2
Right? As the first term, then you're going to add that
to 1.
no. So you generated your first term. Was the next number I'm going to plug into this? So 0 is a 4. So after 0, what else?
You plug in 4.
No. You're going from 0 to 4. So what's after 0?
1.
Right. So your next term will be 5 to the power 1 minus 2. What would your next term be?
5 to the power 2 minus 2.
Plus
5 to the power 3 minus 2.
plus Zachary?
Or
That's the last
5
one.
to the power 4 minus 2.
Okay. So 5 to the power minus 2 is what? What is 5 to the power minus 2?
5 to the power minus 2 is
So if you're not sure, check it in your calculator.
that's 1 over 25. So
Right? So the first term is 1 over 25. What is the next one?
5 to the power minus 1.
Right? Which is
1 over 5.
Then 2 minus 2 is
5. 0. So 5 to the power 0 is 1.
right. Then
Then 5 to the power of 1, which is 5. And then 5 to the power 2, which is 25.
right. So plug all of that into your calculator. No, Serena. Serena, I want to talk to you. Pop the volume.
Yes, sir.
Right. So Serena, what you do there is it's incorrect.
I read it wrong. I thought it was 5 to the power pi and then like the whole thing minus 2.
Even if you did that right, you had to generate more than 2 terms to see if it's a AP or a GP. You can't figure that out with 2 terms.
I
And
realized that now.
yeah. And if it's 5 to the power I minus 2, I don't think it'll be a GP or a AP because you're raising it to a power and then you're also subtracting. So,
Mm-hmm.
but this over here, this is actually that looking like a GP. And you can see it here when you write it like this. You can see that to get the next term, you're multiplying by 1 over 5. Yeah. So plug that into the calculator for me and let me know what you get. So Serena, plug that into the calculator. And let me know what you get. Serena, you get your answer?
I get 781 over 25.
All right, Zachary, what did you get?
So I get the same answer as Serena.
Okay, bet. Let me just verify that. Right, and that is 31.24, yeah? So you can write your answer as 781 all over 25. Or you could write it as 31.24. Now that's a very archaic, or like, it's a very long way to do the question. There's another way you could do the question. So if you want, so let me just show you the alternative way to work this question out. But Zachary, you understand that first method?
Yes, sir.
But you would not be able to do this. Like if it was to the power 100, now you would not be able to do that. You wouldn't be able to add it 100 times. So there must be a better way to do this question. All right, so Serena, this is what I would advise you to do. I would advise you to at least generate 3 terms, right? Generate at least 3 terms, and you can say, well, plus dot 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 plus 5 to the power 4 minus 2. So generate at least 3 terms plus dot 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 plus the last two. We're looking to see if it's our GP or AP. Well, you're gonna end up with 1 over 25 plus 1 over 5 plus 1 plus dot dot dot, and that'll be 25. And that's the last term. Now, Serena, by looking at the first 3 terms, could we prove that they have a common ratio?
Yes.
If you talk, if you're talking, I'm not hearing you. Try talking.
Yes.
Yeah, we could. So let me just prove that quickly. So if you want to prove that common ratio, you can say 1 over 5 divided by 1 over 25. What would you get?
5.
Right, you get 5. And then you can't just do it for one, eh? You cannot just do it for one. It's a common ratio for a reason. It means that it's common between all consecutive terms. So then you could try 1 and 1/5. What would you get?
5.
5. All right, cool. So Zachary, by doing this, we could clearly see that this is a what? A arithmetic progression or geometric progression.
Geometric.
Okay. And do you think that this, well, we know, okay. Serena, would I call this a finite series or infinite series?
Will be finite.
Right, Zachary, do you know what I mean by finite series and infinite series?
Like if we do have an n?
Yeah. But this has an end, so you say as a finite series.
Yes, sir.
Now, if it did not have an end, would you say that this is a divergent series or a convergent series? If you had to say, would it be a divergent series or a convergent series?
Convergence.
Serena, you think this will be convergent?
No, sir.
No, Zachary, check this out, right? Zachary, look at the screenshot you took. What va
Yeah.
what would R have to be to give you a convergent series? Wait, I don't think I include that in the table. My bad. Let me add that to the table quickly.
For it to be convergent, it had to be R had to be less than 1.
Right.
So since R greater than 1, this one will be divergent. So
Right. And you can see it too because the value is getting bigger and bigger and bigger.
yes, sir.
So for a convergent series, the magnitude of R is less than 1. I'm checking something quickly. Right. Right. So once the common difference is not zero, the arithmetic progression will be divergent. Okay, cool. Yeah. So Zachary, if this thing didn't have a limit, it would have been divergent because you could see that we're multiplying by 5. So each term would get bigger and bigger and bigger and bigger and bigger.
Yes, sir.
Okay, great. So let's wrap up this question. Huh? So Zachary, um, we know what R is. R is equal to 5, and we want to find the sum up to the we want to find the sum up to the what term. Now you gotta be very careful here, Zachary. If you're starting from 0 and you're going up to 4, how much terms is that? How much terms you generating? You're generating 4 terms?
Answer 5.
5. So you will want to find the sum up to the fifth term, right? Okay, great. Now tell me, according to the table, which S of n formula you should use?
So you would use A bracket R to the power n minus 1 bracket over R minus 1.
A brackets.
R to the power n minus 1 bracket all over 1 minus R.
Now, remember the trick. Whatever it have on top will be in the bottom. So like R to the power n minus 1. So R minus 1 in the bottom. Because I think it had told me 1 minus R. There will be R minus 1. All right, Zachary?
Yes, sir.
I think about it, Zachary. If it was 1 minus R, and if R is 5, that'll give you a negative number. That'll give you a minus 4. But we don't want
Yes,
a negative number. That's why we use an R minus 1. So 5 minus 1 is 4. All right, so let me plug in here. So we want to find the sum up to the fifth term, so S5. What's my first term?
0.
Nah, my first term is not 0. What was the first term in
1
these?
over 25.
Right. I should probably write that down then to avoid confusion. And R is 5. So that'll be 5 to the power 5 minus 1 all over 5 minus 1. So I'm going to plug that into my calculator and let's see what we're going to get. Imagine having a sharp, guys. Zachary, you don't have a sharp, right?
Answer.
Okay, good. You see, we get the same answer. Right? So Serena, if you was gonna do it the approach you took, you'd have had to do it like this. So Serena, if let me know if you're confused by anything.
I understand now, sir.
You good?
Yes, sir.
All right. Now, honestly, for this question, I advise you to just do this. That's like the easiest thing you could do. However, Zachary, you understand why I'm showing you this? Because like what if they had asked you to find up to the 20th term? What you do in that situation? Would you just keep generating until you reach the 21st term?
Nah, sir.
No, you would not do that. You would have generated a couple terms, see if it's an AP or a GP. Once you see it's an AP or a GP, you could proceed and use the S of N formulas. So that's the plan.
Yeah.
All right, part E should be really, really simple. I think you all should be fine with that question. So Zachary, tell me, how would I answer part E?
Yes, sir. You see, this sequence is convergent because R is less than 1.
That is all. And you will need to prove that, right? So you need to find for R. So to find for R, we could say minus 2/3 all over. Wait, give me a second. Hello? 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 Hey, I was supposed to send you a message and tell you I'm coming tomorrow. Yeah. I will. I'm not coming home though. I'm going to school and I'll reach. Yeah. Yeah.
Okay, no problem.
All right. Thanks for calling. You have a good night.
You too. Bye. Where your mommy? She gone?
Yeah, she all right pretty well.
Grandma.
Grandma, same thing as usual.
All right.
Yeah.
Okay, bye-bye.
Bye-bye. All right. Yeah. Are you there?
Yes, sir.
Yes, sir.
All right. So let me continue, right? So Zachary, you can't just say that R is less than 1. You can't just say that. You need to prove it. And to prove it, you need to actually do multiple ones to show that it have a common ratio. So we could say minus 2/3 over 1. And what would that give me, Zachary? Zachary, what would minus 2/3 over 1 give you?
Said I'll get minus 2/3.
Gotta give you minus 2/3. But again, you can't just do it for 1, right? You need to show that it's a common ratio you have. So then we could do it for 4/9 all over minus 2/3. And again, you will get minus 2/3. And if you want, you could do it for this one. So minus 8 over 27 all over 4/9. And you will get minus 2/3. So now you're going to say, since the magnitude of R is less than 1, the series will converge. And if you want to be like very thorough in your answer, you could also state what it converges to. Could one of you guys tell me how I'd figure out what it converges to? Zachary or Serena, how would I know what value my series converges to? I would need to find what?
So would you need to use the S to infinity formula?
Yes, Zachary, did you think about that? You'd have to find the sum to infinity formula.
Yes, sir.
Okay, good. Right. So let me do that quickly now. come to the side and do that. I don't want Ollie to just pass the exam. I want Ollie to do extraordinary. And like, if you want to be on the merit list, I would recommend doing things like this to show that you're very thorough in your working and you understand what you're doing. Right, so Zachary, do you remember the sum to infinity formula?
So that is A over 1 minus R.
Right, A all over 1 minus R. What is my first term?
1.
And R is minus 2 over 3. When you plug that into your calculator, what you get?
So again, 3 over 5.
Yeah, 3 over 5, that's correct. So to complete our answer, we would say, since the modulus of R or the magnitude of R is less than 1, the series will converge to 3 over 5. Everybody okay with these two questions?
Yes, I could just get screenshots of the, yeah.
I mean, I sent these notes after class, eh?
Oh, well, all right. So
Yeah, you'll get access to everything. So that's it. So the next class, we're just going to be doing a bunch of questions on series and sequences. We are done with coordinate geometry. So the next thing we can move on to, it's probably trigonometry. Did any of you guys do trigonometry in school as yet?
and then add maths.
All right.
Maths.
No, sir.
Serena, did you do trigonometry as yet?
No, sir, not in Form 4.
All right, trigonometry is our Form 5 topic. And is an intense one, very, very intense. Trigonometry is very, very, very intensive and long. So we'll start that next class. Actually, I want to do a bunch of questions on series and sequences, so we mightn't start our next class. But I want Ollie to be able to get these series and sequences questions correct. They're easy marks. Additionally, we need to look at applications of series and sequences. So that would include compound interest, simple interest, investments. All those things are applications of series and sequences. So here's what I will be doing. I'm going to send you guys this section on my textbook for series and sequences. I want you guys to do, so we did 2024 already. I want you guys to do 2023 and 2022. So that's your homework, 2022 and 2023. Let me just mark that down. Zachary, and I want to be getting some homework from you, because I'm not getting, I can't remember the last time I get homework from you, Zachary. I remember the last time I get homework.
So let's do the homework. I just forget to send it.
Now, well, don't forget to send it.
Yes, I'll make sure I send it.
Because your word is one thing, but seeing it is another thing.
Yes, no problem.
All right. So that's your homework day. So yeah, guys, hope you have a blessed Sunday night. What's in Sunday night? What? Monday night, Monday night. All your school finish? School over for you guys?
Yes, sir.
Yeah.
Yes.
Oh, a lucky boy. I have UE. Right, true. Yeah. All right, well, you have a good night. Take care. Bye-bye.
Yes,
You
sir.
too, sir.